Welcome back to our series on building apps with Macs. We also call them standalones a lot in the Macs world. And this is the patcher that we looked at in the first part of the series. So if you want to get refreshed, go grab that from the Cycling 74 website. What this is doing is it takes the audio from a drum loop and it has some responsive visuals that go with it. So if I turn this on, and we switch over to the full screen, we can see the visuals. Come back to our main patcher and also look at our project. We made this patch, we turned it into an app, and voila, it all worked. All of the dependencies were taken care of for us. Those are listed here, these different externals, different subpatchers. So that's great. This time, we're going to add some additional dependencies that won't be taken care of automatically, and we'll see how to deal with those. What I'll do is I want to add an effect, an audio effect here, to soften the sound. So I'll go ahead and pull up plugins. This chamber verb live device is really nice. It'll give us like just a little bit of something. So I could drag this over here and drop it in like you normally would. I don't really need this whole interface though, and I'm going to have to rearrange my whole patch. So maybe what I'll do instead is I'll just type in amxd tilde and then type in the name of the plugin that I want. So amxd chamber verb, and if I double click it, then I can get to the UI to change the settings. So drop that in there, then I will option drag over those two chords so I can select them both, move them both, and hook this effect up. Now when I play this, we should hear the reverb. Okay, so that's great. I'll save my patch. And when I do, we'll see that this dependency was automatically picked up by the project. So now when we compile our app, the chamber verb will be there. That's great. I'm already envisioning though, if I have an effect here, what if in the app I wanted to change the effect? To do that, let's do a little bit of scripting. If you're not familiar with scripting, it's a way that you can use this patcher object to create objects, to edit objects, to delete objects that are in your patcher in an automated way. So to begin, every object that we're going to use scripting with needs to have a scripting name so that we can refer to it. So if I open the inspector for the chamber verb, we find the parameter called scripting name. This one already has a scripting name. It was given automatically. So this one's going to be called amxd tilde. That's handy. Let's come take a look at this gain slider. The gain slider we'll need to know because we're going to want to connect our new effect to the gain slider. It'd be here somewhere. Scripting name, live.gain. Great. And then finally, we have a playlist. And the playlist scripting name, playlist does not have a scripting name. So just to be consistent, we'll use the same style. We'll call it playlist tilde. Okay. So now what we'll do is we can send a message to this patcher, and the message can say, if we're going to switch the effect, the first thing we have to do is delete the existing effect. So we can say script delete amxd tilde. And if we want to build up compound messages, we can do that by adding commas here. So we could do two commands in this box. So we could say script delete amxd, and then we can say script new object amxd tilde and the name of some other effect we want. Comer is always kind of a fun one. So we'll do Comer. So if I click this, these two messages will be sent to this patcher. We should delete this object. We'll create another object. Okay, this one was deleted, sure enough. And this new object was created, but created up in this corner. We didn't tell it where to create this object in our patch. So we could do that. The details are in this patcher. I'm going to just keep moving and say that it's okay that this object gets created in the top corner. If we want to connect this, then we need to use connect messages. So we'll add a couple of new scripting commands here. We say script. I think it's connect, but I don't actually remember, so we might have to go look at the help patcher. Script connect, and we're going to start by connecting playlist tilde, which was the scripting name, outlet 0 to amxd tilde inlet 0. And then we can script connect. We can say amxd tilde 0, which is the first outlet, to live.gain tilde inlet 0. So we'll try this. Okay, it deleted that object. It created our new object up here, and it did connect them the correct way. So I remembered, thankfully. So we'll need to also do this for the second channel. I'll just copy and paste this, and we'll say we're going to connect playlist outlet 1 to amxd inlet 1, which is the second outlet and inlet pair, and then we'll do the same thing again. Now, voila, we have a message box that does a little bit of magical scripting for us. So that's fun. We can switch our effect now. I can make a U menu, and the items I'm going to put in the U menu are going to be chamber verb and comer. Oh, I typed it into a message box instead of in a new object box. Okay, there's our menu. If we hook this up to the message box and then change this to $1 so it's substituted, now we can make, oh, rats. I should have put a comma between those items. We'll kind of edit it in the inspector. There we go. Okay, so now we can have comer, or we can have chamber verb. That's great. So if I play this, turn this on, there's the chamber verb. There's the comer. Go back to chamber verb by default. Okay, so I'll save the patch. And then when I save the patch, you'll notice we still have the chamber verb in our project, but we don't have the comer in our project. So when we go and start our app, it won't switch the effect for us because the comer won't be in our app. So how do we get the comer here? Well, there's two ways, it turns out, to deal with the dependency. One is that we can add the dependency to our project. We'll try that first. The other way is we can add the dependency to our bundle, or in other words, we can manually copy it into the folders that are inside of our app. So first, let's add comer, the amxd, to the project. So all we have to do is find the comer and drag it in here. But wait, how do we do that? Can we drag an object like this into the project? No, we can't. That doesn't work. So we have to find it on the hard drive. But how are we going to find it on the hard drive? To do that, we'll go ahead and open up the Finder. We'll find Max. Our copy of Max is right here. If we right-click on it or control-click on it, we can say Show Package Contents. In there's a Contents folder, in which there's a Resources folder, in which there's a C74 folder, and in the C74 folder, there's a Packages folder, and in the Packages folder, there's all the packages that ship with Max, as opposed to those that you're installing from the package manager. So in the packages that we ship with Max, there is a Max for Live package, which has patchers in it. And in the effects, we find the chamber verb, which we already have over here, but it's implicit. So if we want to make it explicit, we could go ahead and just drag this folder in like so. That will also bring in the presets. And then the comer we could also drag in like so. And now when we come over here, we're going to see there's some additional stuff, including chamber verb, AMXD, and apparently I didn't get the comer to take. There we go. And now there's comer AMXD. They're both in our project now. So let's go ahead and we will try building this and see where it gets us. First we'll save our patch, and we'll come over here, and just as we did in our first session, we find build collective and application, choose application from the file format menu, and we build it onto the desktop. Now, I already have something on the desktop, and sometimes it doesn't work cleanly if you build on top of an existing app. So my suggestion is to delete the previous app before building your new. Okay, again, this is going to take a minute. You'll have to remember to be patient through this process of building, and it will take longer than what you're seeing in this video, most likely. Okay, so it built our app. We can start that up and try it. Let's go ahead and quit Max, just so we don't get confused. Start up partypatcher.app. Okay, I don't hear anything in our effect. Let's come look at our main patch. So what's happened here? If I double click on that, nothing is opening. If I double click on these patchers, they do open. So something still isn't quite right. If we choose to switch the effect, it does seem to switch here and appears to load, but we still aren't hearing anything. So what's going wrong? Well, we're not sure. We can try to look at the Max console, which is still available to us in a standalone. What this is telling us is Max tilde, it can't find this patcher, or it can't find the chamber verb patcher. It's looking for this patcher C74 packages Max for Live patchers, etc., etc. But that isn't really working. Let's decode this message. Max tilde is the internal name for AMXD tilde. So this is really saying that the AMXD tilde can't find chamber verb in this particular path, where C74 is the C74 folder that we saw inside of the Max application bundle. If we look at this app, we can open it up again, just like we opened up the Max application bundle, and we can say show package contents, resources, C74, and there is no, well, there is a packages folder, but in the packages folder, there is no Max for Live package. And there is no, there's no place in this folder structure where we're going to see the comer and the chamber verb. That's because when we added the comer and the chamber verb, we added them to the collective. So a little review from last time, we touched on it only briefly. In the Mac OS folder, we have the exe, as we would think of it on Windows. This is the thing that's actually going to execute code like Max does. But then we also have a collective, and that is in this resources folder down here, partypatcher.mxf. So in this collective file, we have added all the dependencies so far from that project. In some cases, that is not adequate. And this appears to be one of those cases. So now we can look at the other approach to dealing with dependencies when the project window isn't going to work. So that approach is that we manually add things to this folder after the app is already built. Let's do that manually here right now. So I'll go ahead and let me quit our app. Here's the Finder. We'll make another Finder window and we'll go find the Max application again. And in the Max application, which I can right click on, show package, contents, we go for resources, C74, packages, Max for live. We could bring in the whole thing if we want, or we could just bring in the part that we want. It's going to be easiest for right now just to bring in the whole package. It will add more size to our standalone, so that's another thing to consider with dependencies, and we'll address that a little later. Max for live. Okay, we just added an alias. That's not what we want to do. We want to actually add the real contents of this. So I'll hold the Option key while I'm dragging on the Mac. On Windows, I would probably hit Control C over here and Control V when I got over into this packages folder that's in our app. Okay, so we've added this resource into our Party Patcher app. Now when I double click Party Patcher, we can hear the reverb. So that's a great start. And then we can come to main and we can try to switch the effect, and that works as well. So now we know what we need to do to make this work. First we'll get Max started up here. Oh, now let's look at the project. So adding all this stuff to our project didn't really work, so I'm going to go through, and if I highlight something, I can click the delete key. So I'm going to delete all of the stuff that we added that we don't actually need to keep our project nice and tidy. It'll take just a moment. We can't select multiple things, so we'll just do them one at a time. Okay, so I think we got that. This one is implicit, so it's just going to be there. This max snap is the snapshot that represents the settings for the chamber verb. So I think we are all set here. We can save this now, but if we rebuild it, then what's going to happen is our other app will get blown away and it will forget that we added this folder. So how do we deal with that? Well, we could just remember that every time we build the app, we have to copy these over. That ends up being a little bit of a drag, especially if we end up with a lot of different resources that we need to monkey with. So what I like to do is I create a script, and then after I build my app, I run the script. And the script can then do all kinds of things with our app. It can change the icon, it can make other modifications that we need, and it can try to remove resources that we don't need so that we can reduce the size of the app. So let's look at how we do that. So to begin with, I'm going to start a text editor. I like the TextMate editor, but there's plenty of other coding editors that you can use, whether it's an Atom editor or a Sublime Text or what have you. It should just be a coding editor. And I'm going to do a little bit of coding in Ruby. Ruby is available on the Mac automatically. On Windows, you can install it from rubylang.org. So to get started with our Ruby file, I'll save it before we do anything else. And for now, I'll save it on the desktop. It should have a .rb extension to it, and I will call it Party Fixer. So now we know we run party fixer every time we build our standalone app. To get started with, we need a little header thing that tells us that, that it needs to run using Ruby. So there's a Ruby bundle in TextMate that will do this for me, so I don't have to remember exactly how it's supposed to be typed. So I do that. And now I can type in my various Ruby commands. The problem is I never remember the Ruby commands. So I'm gonna real quick load up Safari here and say Ruby copy file. Okay, and here's the documentation for it. So here's the reference, and we're gonna look for, here's copy file, that seems good, or maybe just copy, which probably copies folders or files. So copy is an alias for CP, so I guess I should go look at CP, which is down here, and copies file content source to desk, that's what we want. So here's an example, file utils.cp, and then 2 arguments. Alrighty, so we'll do file utils.cp, and we have 2 arguments. And the first argument is going to be the source, and the other one's going to be the destination. So if I come to the Finder, I'm not sure if I can just drag this in here or not, but I'm going to try. Nope, it won't let me. What I can do is if I open up a terminal, this is on the Mac, but in Applications Utilities, there's the terminal app. This app, I know if I drag a folder onto it, it will give me the path to that folder. Okay, so I can copy that path, which is the source, and we'll put a comma, and then we will have the destination, which is going to be in our standalone app over here. So it's going to be like that. So we're going to have quotes in it, and I need to use the terminal again to drag this one. That gets confusing. Let's oops, make a new window. Drag that down, copy it. Okay, let's see if that will do the trick. On the Mac, to run this, we're just, like I said, it's already built in. So we say cd to the desktop folder, because that's where we save the file. ls is a command that shows you a directory listing, and -l gives you like a longer listing. We see we have the Party Patcher app, and we have the Party Fixer RB. So we can type Ruby, and then we do Party Fixer RB, and hit enter. It has an uninitialized constant file util. So what that means is that it was supposed to include this file utils thing somehow. In TextMate, I can use that Ruby bundle again and say insert missing requires, and it took care of it for me. Okay, that's great. Okay, so let's rebuild our app and run this script and see if it works. To do that, we'll start over in the Finder, and we'll come back to our desktop, and we will delete our Party Patcher app. And we'll switch back over to Macs and pull up the project window. Make sure everything's saved, and then we can build our app. And once again, this is going to take a couple of minutes in real life, but in video time, it'll just be a few seconds. Okay, so it's done. We'll quit Macs. We have our Party Patcher that we have not processed with our fixer script yet. So if I start it up, we should not hear the reverb, and we don't. So I'll quit that, and now we'll run the script. So we can go back to the terminal, and we can try running our script again with Ruby party fixer RB. Okay, and it output a whole bunch of stuff. It looks like we have another problem. Copy stream is a directory. Okay, so I needed to do something different for copying the directory. And what is it that I needed to do? Oh, I already know. I need a cp_r. And if we had taken the time to read this whole page, we would have found that out. So let's switch that around. The _r means recursive, so it's going to recurse through directories, subdirectories, etc. Okay, try again. Okay, this time it ran. There's no errors or anything here, so hopefully that means it worked. To find out, we can test it. And we hear the reverb. So this is great. So every time we build now is actually going to be a two-step process for us. First step is we compile the application with Max, and then the second step is we run this little script. And right now the script is adding some of our additional dependencies for us. Let's now take another look at the patch. There's another aspect of dependencies we can talk about. And we'll do that by adding a standalone object to our patch. The standalone object is for standalone apps, and what it does is it lets us set some different attributes about the patch. One thing we noted in the first installment of this series was that our app is almost 400 megabytes. We'd like to slim that down by getting rid of dependencies that we don't need. One place we can attempt to do that is in this standalone object. There are a bunch of attributes, and we'll look at what some of these do, like the bundle identifier later. But one thing this does is it will give us a way to possibly remove some dependencies we don't need. So for example, we could remove Gen Support, and that'll take some stuff out of the application bundle. We could also remove Cef Support, and that will take some stuff out of the application bundle. Cef is, if we just highlight over the I, it tells you it removes support for the JWeb object. Unfortunately, it also removes some other things, and it's not obvious what the dependencies are. So you can just try it and see what happens. And sometimes you'll be surprised. You'll be surprised in this case because our app will crash. The same is true with Gen Support. There's no obvious place here where Gen is used, but if we remove that, then this app will crash because some of the JitterGL stuff under the hood is using some of the Gen technology. So actually, we can't click those things to reduce our standalone size or manage our dependencies. What we could do, if I save this here, is we could go to our script that we started to create, and we could start removing things that we know we don't need. So what things do we not need? Well, let's show the package contents. I will also add, I don't recommend removing things you don't need early on. This is an optimization that you would do toward the end of your development, because otherwise you might end up removing things you have to add back in later anyway. There are things we could remove here that won't yield us a lot of extra space, but we could remove them. Here's some icons that are included. We don't need snippet icons, for example, but it's only 77 kilobytes. So it's not going to gain us much. On the other hand, if we were to come in and look at the C74 folder, there might be other places where there are some bigger savings to be had. For example, the Java classes, we are not using Java at all. If I do get info on this, we can see that this is 2 megabytes. So we could remove Java classes if we wanted to save 2 megabytes. But remember, we have a 400 megabyte application, so you might weigh whether or not you're really helping yourself that much. One easy way to slim down our application is to remove the 32-bit executable. At least on the Mac, all computers that support the current versions of Macs support 64-bit applications. And right now, this version of our app is a universal binary, contains 32-bit and 64-bit binaries. So we could get rid of the 32-bit ones unless you are using some features that specifically require 32 bits. To remove that, we have another little bit of geekiness that we can put into this script. We could also go searching for information online about that. We do like Max, standalone, lipo. We can see, for example, there is a whole post on the Cycling 74 forums. So let's copy and paste this, and before we go and add it to our script, let's test it out in the terminal. So the first thing we can do is we can actually run a command lipo info, and we could do that on our app. If we do that, it's going to say there's an error because partypatcher.app, even though it looks like a file, is actually a folder, which we know because we've been breaking into it this whole time. So the part that we actually are going to try and run this lipo command on is going to be the executable part or parts. One of those parts could be these various libs that are in the frameworks folder. One of them is this executable right here. This is 25 megabytes currently. And if we look in resources and we come here and look in externals, then it would apply to each and every one of these externals. However, the externals, I should also tell you, are bundles, and so they're actually folders. So we have to show the package contents, and we could drill down in here and do this for all these. However, we're looking at the anal object right now, and we don't use the anal object in our patch. So maybe we don't need that at all. In fact, all of the objects in our patch that are used should be included in the collective. So maybe we could just delete all of these. Maybe we could delete all of the MSP objects. We're not really sure exactly what's going on, so the only way to find out is simply to try. So what happens? We'll just take it one step at a time. If we do a whole bunch of changes at once, then it might not actually be clear what the source of any problems are. We'll come back to Max. We're going to quit Max. We're going to take a look at our patcher. Okay. Let's start this up and see if it works. It may or may not. It does work. And if we want to check, we can always look at the Max console. Okay. Let's do that again. We can go through and with this discovery, we can probably thin this app down quite a bit. Let's try removing jitter, Max for Live, MIDI drivers, and MSP. We can even try removing the entire externals folder, because I believe that those are probably included in the collective. We'll find out for sure by testing it. And now it doesn't work. So the Max console window will probably tell us what's missing. Hopefully it'll tell us what's missing. Okay, the AD folder and the MIDI driver folder generated errors. Okay, so let's come back here and we'll add those back in. Resources. We'll come down here to our trash can, and we can find the externals folder. We'll add that back, and then we'll add in the AD folder to that, and then we'll give it a go. Okay, now it appears to just crash. So we could try to diagnose it from this crash log. Sometimes these look like gobbledygook, but sometimes there's a hint that we can actually manage to decipher without being a internal cycling 74 person. And here I can see playlist, and playlist is having some kind of problem. So what is it that playlist needs? We are not sure. We could just start adding things back, or we could add back the thing we wanted. At some point this might not make sense to spend all this time and effort on it, but maybe you really want to slim down the size of your app, and it does make a difference. In this particular case, I know that the playlist object uses SF play internally, and so I'm going to go ahead and bring the SF play object over. We can make a little folder in here called MSP, and into that we can do SF play. And I know that if you use SF play for playing back MP3 files, that actually is going to use a buffer object internally. So what we're doing right now might be a little crazy. It's definitely tedious, but we could potentially do this. Let's just try the app and see if it works now. Okay, now it does work. So it works, and what is the size of our app now? The size of our app is down to 360 megabytes. So we still haven't like completely thinned it out, but we could go through. So this lipo thing that we can do, had gotten distracted here, but we did lipo info partypatcher.app, and that didn't work. So because remember, we needed to go over here and look in our application bundle to find out where the stuff is. And so one of the things is right here, it's in the subfolder contents macOS party patcher. Okay, so let's go. So contents macOS party patcher. So lipo info tells us that this is 32-bit, that's what this i386 means, and 64-bit. So if we want to try this command that we saw on the Max forum, then what we need to do is we need to substitute all of this for my app. I'm going to just do this. And this. Didn't like that. Okay, so according to that manual, we need to run this command maybe with a specified output, and it looks like maybe I need to specify that by saying output like that. Okay, so we just ran that. Now I can see it produced this thing called Party Patcher 64, and we can see that it's half the size roughly, so 13 megabytes instead of 25. So I could delete this one. Okay, and now that we have put this one on a diet and cut that size in half, like I said, we could do this with these frameworks and other things as well. Now we could try running this Party Patcher. See if it still works. Switch to the comber. Oh, now there's comb no such object because that was a dependency of this other AMXD. So this is the reason that all of those externals are there, because if something is dynamically loaded, you don't know what objects it might need. So they're just all included in there manually. Anyway, this is a rabbit hole that you can pursue or not, this whole thinning process. The lipo command, if you wanted to pursue that, is one of the things that you would go ahead and add here to this script. So maybe we'll do that now before we forget about it. and we'll need the path entirely slash desktop. So we would do that, and then we would go ahead and use file utils to delete, file utils to move. So we have to go back to the reference page for Ruby, history. Okay, and we can come down here. There's going to be remove, also RM, which would also be a remove, and there's going to be move. Okay, so remove this one, which is the fat file, and move this one to the original name. There we go. Just like that. So hopefully that wasn't too exhausting. We do have an app, and well, it's easy to make a simple app. If you're trying to do more extravagant or advanced things, it does become more and more challenging. As we dig into these nitty-gritty details, hopefully your tool chest will expand and you'll be able to realize all of your dreams. It's just a matter of work. Until next time, happy patching.